In the previous session, we discussed about the notion of antiderivative or indefinite integral. In today's session, we're going to discuss about the so-called definite integral. In order to establish the results of definite integral, we need an important theorem, so-called mean value theorem. Here, in order to prove the mean value theorem, we shall be using the result of another theorem known as the Rolle's theorem. The statement of the Rolle's theorem says that if g of a equal to g of b for a less than b and g of x is a smooth function, that is, it is continuous on a closed interval a comma b and differentiable on an open interval a comma b, then there exists a point C such that g prime at C is equal to 0. Now let's try to understand the statement of this theorem from this graph. So from the graph itself, you can see that if the function takes same value at x equal to a and x equal to b, then there will always be a point C where the slope of the function g will be 0. That is essentially the statement of the theorem. Prove this theorem by contradiction. Let's assume there exists no such c inside the interval a comma b such that g prime at c equal to 0. This then implies that for all c belongs to the open set a comma b, that either g prime c is positive or g prime c is negative, as g prime c equal to 0 is not allowed. So it could be either positive or it could be negative. Now it is given that gx is differentiable at all points c in the open interval a comma b. Open interval means the endpoints are not included. Then g prime c by definition of derivative can be expressed as limit h goes to 0, g of c plus h minus g of c divided by h. Now we can then rewrite g at c plus h to be gc plus g prime c times h as h goes to 0. Now in case the g prime c is positive, that would mean that g at c plus h is greater than g at c given h is positive. Clearly, then I can establish an inequality where g of a is less than g of a plus h, which is less than g of a plus 2h, and henceforth, which is less than g of b minus h, which is less than g of b. So as you see, the inequality then implies that g of a is less than g of b, which contradicts the given statement, that is g of a equal to gb. Hence, our assumption must be wrong. Therefore, there must exist a point C such that g prime c is equal to 0. As earlier, we can prove an inequality even for the case where g prime of c is negative. In this case, g of a will be greater than g of a plus h, and which will be greater than finally g of b. Again, this contradicts the given statement, that is g of a equal to g of b. Therefore, even for this case, there must exist a point C in the open interval a comma b such that g prime of c is equal to 0. So, which proves the Rolle's theorems. Now we are going to use Rolle's theorem to prove the so-called mean value theorem. The statement of the mean value theorem says if f of x is a smooth function, that is, it is continuous on a closed interval a comma b and differentiable on an open interval a comma b with a being less than b, then there exists a point C in the open interval a comma b such that f prime of c is equal to f of b minus f of a over b minus a. Now let us try to understand the statement of this theorem from this sketch. So as you can see, fb minus fa over b minus a represents the slope for a straight line that goes through these 2 points, f of b and f of a. And the statement of the theorem basically says there is a point C in between a and b where the slope of the tangent line is same as the slope of the straight line going through the point fb and fa. In order to prove the mean value theorem, let us choose a function g of x such that fx equal to gx plus rx, where r is an undetermined number and g of a equal to g of b. Then Rolle's theorem implies that there is a point C such that g prime of C equal to 0. Then it implies that a prime of C is equal to R. Now by construction, g of A equal to g of B, which then implies f of A minus Ra equal to f of B minus Rb, clearly we can then determine R to be fb minus fa over b minus a. Now we have already established using Rolle's theorem that f prime of C is equal to R, which is then equal to fb minus fa over b minus a, which is the statement of the mean value theorem. Let us now consider an example where we verify the mean value theorem as you see it here. Firstly, the slope of the straight line that passes through these 2 points, as you see it here, is given by fb minus fa over b minus a, which is equal to 1. Secondly, we can compute the slope of the tangent line, which is the derivative of f. Now we can see here that there indeed exists a point c equal to half, which lies in the interval 0 to 1. I hope you have enjoyed today's session. In case you have any question, comment or suggestion, please feel free to write them below in the comment section. And if you like to follow the physics discussion here, then you are welcome to subscribe to this channel.